Hello everyone, welcome to another one of our short video series. In this video, we will learn about light reflection. At the end of the session, students should be able to draw a light ray diagram for plane mirrors and locate mirror images. Before we can draw light ray diagrams for mirrors, we need to know the properties of image formed by a plane mirror. The image has these properties. It has the same size as the object. Image is laterally inverted, which is a left-to-right inversion. It is upright. The image is virtual, meaning that it cannot be captured on a screen. And the object distance, which is the distance from the mirror to the object, is the same as the image distance, which is the distance from the mirror to the image. Even though infinite number of light rays are reflected, only some of the reflected ray will be captured by the eyes. These light rays captured by the eye give us the image that the eyes can see. In the diagram, only the blue ray enters the eyes, which enables the eyes to see it. The image appears to come from behind the mirror. This is another reason why it is called a virtual image, because no light comes from the image. Let us now focus on the steps involved in drawing the image formed by plane mirrors. The first step is to draw the image. In our example, the image of the triangle is a triangle of the same size and shape, as far back behind the mirror as the object is in front, but laterally inverted. Step 2 is to draw two diverging rays from any point on the image towards the eyes where the eyes is positioned. In fact, one light ray from the image is sufficient as long as it can maintain line of sight. It is customary to draw bowlines for the refracted ray, that is, from the mirror to the eye, and a dashed line as an extension of this reflected ray. The dashed line extends behind the mirror to the location of the image. The reflected ray should also have an arrowhead upon it to indicate the direction that the light is traveling. The arrowhead should be pointing towards the eye, since the light is traveling from the mirror to the eyes, thus enabling the eye to see the image. Step 3 is to draw the incident ray for the light traveling from the corresponding point on the object to the mirror where the point of reflection is. This will complete the light ray diagrams for the plane mirror images. Let us practice what we have learned using this example. Step 1, we draw the image, which is also a dot, but the image distance must be the same as the object distance. Step 2, we draw a light ray as if it is coming from the image to the eye, ensuring that there is line of sight. Step 3, we complete the light ray by drawing from the corresponding point on the object to the point of reflection. We can also add a second line, repeating step 2 and 3. Note that the lines behind the mirrors are dashed. Recall that there are two laws which govern reflection. Number 1, the incident ray, the reflected ray, and the normal all lies on the same plane. And number 2, the angle of incidence is equal to the angle of reflection. How are the laws of reflection embedded in the 3 steps that we use to draw the light ray diagrams of plane mirrors images? Pause the video and think about the answer. In step 3, the incident ray reflects at the mirror surface according to the law of reflection. But rather than measuring angles, you can draw the incident ray from the object to the point of reflection on the mirror. This will ensure that the angle of incidence is equal to the angle of reflection. Not all mirrors are plane mirrors. We also have curved mirrors. In the case of curved mirrors, the law of reflection holds for curved mirrors. However, the sizes and distances of objects and image are no longer equal. It depends on how far the object is, and this distance is broken into 5 segments for a concave mirror as shown in the next slide. Depending on the object distance, different images are formed. This slide is for your information only, and there is no need for you to study the information in detail. Likewise, for a concave mirror, the image type depends on the object distance. Here, the object distance is divided into just 2 segments. Once again, the information herein is just FYI. That's all for this video. Be sure to check out our other videos.